So some of these kind of equations, when we solve them, you get a lot of answers, but they don't all work. So I think both questions 4 and 5, you kind of run into that. So for question 4, I'm just going to kind of start working on that. And it doesn't seem like you're having trouble solving these, which is great. It's just the answers at the end for a lot of us. So on question 4, I would have gone ahead and changed secant to 1 over cosine. Then I probably would have thought about cosine as cosine over 1. Tangent I would have changed to sine over cosine times sine over 1 minus 1. On the left, I would have gotten a common denominator by multiplying by cosine over cosine. So I would have 1 plus cosine squared over cosine equals sine squared over cosine. And I probably would have made that 1 a sine over sine so that I have a common denominator, or excuse me, a cosine over cosine, lies. So that I have a common denominator. So that makes this minus cosine all over cosine. When you have the same denominator on both sides, essentially, you can just eliminate that. So that then gives me 1 plus cosine squared equals sine squared minus cosine. And if we're kind of playing the game of what doesn't belong, it's really this sine squared. So what can we change out the sine squared for?
1 minus cosine squared.
So I can do 1 minus cosine squared. And then I would treat this like a normal factoring problem, move everything to one side and factor. And like I said, with the questions I've seen on this one, y'all aren't really having trouble with like this process, which is great. When I subtract 1 from both sides, that would then cancel those out and I would have this. I would factor out a cosine, which leaves me a 2 cosine plus 1, and I would set these equal to 0 and solve. And here is where we end up having kind of a problem, because you're looking for where is cosine equal to 0 and where is cosine equal to negative 1/2. Anytime you have fractions in the original equation, and I don't mean like it has to have an actual fraction bar in it, it can be implied fractions. So going back to the original, secant has a representation that is a fraction. Tangent has a representation that is a fraction. You could get answers that don't work, and that's what happens here. Secant's representation is 1 over cosine. If secant is represented by 1 over cosine, does it make sense for cosine to be 0?
No.
No, because we're not allowed to divide by 0, right? And I recognize that that makes secant undefined and that we have values for where secant is undefined. That's fine. But if you plug that back in everywhere to the original, that's saying undefined plus 0 is equal to undefined times sine would be 1 minus 1. And so yes, while we have separate values for each of those, and where you have cosine being 0, secant is undefined, that doesn't make the equation true. So you can't say that undefined plus 0 equals undefined minus 1. Like that doesn't actually make sense. So that's why we would eliminate cosine being 0 and only get the answers for where cosine is negative 1/2.
So
Let me get rid of this real quick because I have more people trying to get in. So that's kind of what you're seeing on some of these questions. So there, like that's why if you look at the answers for that particular question, number 4, you only have 2 pi over 3 and 4 pi over 3 where cosine equals negative 1/2. You don't have any answers for where cosine equals 0. Does that make some more sense on that one?
Yes.
Yeah.
If you had like a question like that and you plugged it in and it gave you like a 0 plus undefined on one side and then a 0 plus undefined on the other side, or something that was like actually equal.
That actually made sense. But that's still not going to be okay because of the undefined. Because honestly, like in our heads, we're thinking, yeah, undefined plus 0 is undefined plus 0. But what's undefined?
Okay, so if there's ever an undefined, it won't work.
Essentially, yes. Now, That's not to say I'm going to try to trick you all over the place. So please don't expect these to be like every question.
And if it was just like it came out to be 0 equals something else on the other side, can
Mhm.
that happen? That can happen, right?
0, yeah. Oh, yeah.
Okay.
0 is a number. It's defined as a certain value. That's totally fine. Undefined is the sketchy one. And so,
Okay.
like, honestly, I kind of know which ones to look out for on that. Anything that has a secant, a cosecant, a cotangent, or a tangent in it would be ones that I'd have to check for something like that. Because of them being defined as a fraction. Something like question 6, I'm not even going to worry about it because cosine always has actual values.
Ms. Leininger?
Yeah.
So on number 4,
Yep.
I did it a little differently, and so I never got cosine equals 0 because I could like cancel it on top and bottom.
Yes.
So when are we allowed to and when are we not allowed to cancel out functions?
I try to never do it because of the fact that, like, it's totally fine and it worked out fine for you there. But, like, I try to never cancel out fractions because I would rather get to the place where I consider my answers and say that they don't work and cancel it out there so that I'm actually thinking about it. Whereas on your method, you never actually thought about the fact that the cosine didn't work. You know what I'm saying?
Yes.
Because there was one on the quiz that was that way. And if you canceled out answers, you actually lost answers that worked. So I try to never cancel out functions and always get to the point that I have cosine equals this, and then decide if they work.
Ms. Leininger?
Yeah.
So if you have like something over cosine equals 0, on
Mhm.
some of them, I've just like multiplied by cosine on both sides and it got rid of the cosine.
I try to not do that.
Okay, because it still gave me like the correct answers.
It does in that case because you wouldn't have gotten answers from cosine to begin with.
Okay.
But again, I try to not cancel so that I can make that decision.
How do you do it with not canceling? Like if it's just
if you had 1 over cosine is equal to 0, rather than multiplying the cosine to the other side, this is where I would just flip and say that means cosine is equal to undefined. That's the same thing. And then I think about the fact, does cosine ever equal undefined?
So if there was like stuff on the top, like instead of 1, then what would you do?
I can't see that happening.
Because
I mean, with a 0 over there.
let's see. Okay, there's a question that I did something like that, but it comes up later, so I'll bring it.
Okay, think about that one. Do we still want to go over question 5?
Yes.
please.
Okay. Question 5 is an interesting one because of the solving technique. I worked on the left-hand side to begin with and started with tangent being sine over cosine, secant being 1 over cosine. You have a common denominator already, so that makes it sine minus 1 over cosine is equal to root 3. Back when we did proofs, we talked about the fact that essentially it's impossible to replace a single sine or a single cosine by itself. So the easiest thing to do on this case is to move the cosine over here and actually square both sides. By squaring, it's going to force some of my Pythagorean identities, which is going to then allow me to solve. So I have sine squared minus 2 sine plus 1 is equal to, because that's on the left, I'm actually FOILing the whole thing out. The root 3 squared is just 3 cosine squared. Again, kind of playing the what doesn't belong card. It's the cosine squared there. So I would then take the cosine squared and make that 1 minus sine squared. Again, I feel like a lot of us kind of got through some of the solving once we recognized that you had to square both sides. This is going to give me 3 minus 3 sine squared. And this one you also eliminate answers at the end, but it's for an odd reason. So it's a good one to talk about. When I subtract the 3, it gives me minus 2. I would take out a greatest common factor, which you can then just ignore because it doesn't affect anything. Factoring, we get 2 sine and 1 sine. And then factors would be minus 1 plus 1. So we go through, and honestly, if I wasn't thinking about the fact that some of the answers will not work, I probably would not have thought about it in the end part of this one. But here's what happens on this one. Your original function has fractions in it because tangent's defined as a fraction and so is secant. I recognize that these are sine values. Sine is equal to -1/2 and sine is equal to 1. But what's in the denominator of your fraction? In the original?
Cosine.
Cosine, right? So even though you have sine values, you need to think about when sine is -1/2, what is cosine? So if I think about that in my chart, I don't even have to think about the negatives. I just look at where sine is 1/2, cosine is going to be √3/2. That's fine. What about when sine is 1? Go to your chart. When sine's 1, what's cosine?
0.
Is that going to be okay?
No.
No. Because you could keep going to the answers and then eliminate them. So for example, I could say sine is -1/2 at 7 pi over 6 and 11 pi over 6. Sine is 1 only at pi over 2. And I could take those and plug them back into this to then see what the problem is. I don't really like to plug those in and say at 7 pi over 6, the cosine value is -√3/2 and work with that, because that's not a whole lot of fun. So that's why I stop back here to check my answers by recognizing that when sine is 1, cosine is 0, that tells me the bottom here would be 0. And then I just eliminate that and don't ever look for those answers.
So why is there only one answer?
What does it say there? Let me see. That's a good question. I think that's wrong. I think there should be 2 there. Personal. I disagree with that because I believe 11 pi over 6 would be just fine as well. There's no reason for it not to be. So, yeah. Other questions on this page before we look at the second one?
The one that Nick was doing, he said he crossed, or the fourth one, he said he crossed out. Was that just like lucky that he crossed out and it didn't work?
Yeah. Because like, I think your quiz, if you look back at question number 5, some people canceled there, but those answers did work. So it's kind of hit or miss. If you cancel, sometimes it's like they wouldn't have worked anyway. And sometimes they would have. So it's not really a great thing to ever cancel out. It's just like when we were canceling out X's in the fall, we lost answers from that too. It's not a good practice to cancel out functions, basically.
Can we do number 8?
Yeah. Number 8 is actually very similar to number 5 in the way that you do it, and has some of the same problems with it. I would rearrange in question 8 first by moving these 2 to opposite sides. So I would have cotangent minus cosecant, and at the same time, I would make that cosine over sine minus 1 over sine is equal to move the √3 to the right. And then I would handle this almost exactly the same way that I did the last one.
You have cosine over sine? In the, why is it?
For cotangent?
For cotangent?
Yeah, I replaced.
Oh, yes. Okay, you did it like that. Okay.
Okay. So then I multiply my sine over here and then square both sides. So that's what would give me cosine squared minus 2 cosine plus 1 equals 3 sine squared. I would do just like I did on the last one, replace the sine squared with 1 minus cosine squared. And then solve from there. So this would then, I would move the 3 to the left. The 3 cosine squared give me 4 cosine squared minus 2 cosine minus 2. It's exactly the same factoring as the previous one. Kind of start to recognize the factoring on these because I can't really do too many different factoring versions and actually have them work for answers. So then I would factor this into cosine minus 1 plus 1. And you run into the exact same problem here. You get cosine equals -1/2 and cosine equals 1. if I think about the original representation back here when sine is on the bottom, when cosine is negative a half, sine is either positive or negative √3/2. That's fine. When cosine equals 1, which happens at 0, what is sine? Zero. So I can't have that. So I would eliminate that there and just look for where is cosine equal to -1/2.
So-
Miss Linda,
Hmm?
is there ever a time when we'll have to eliminate solutions, but we didn't use a fraction while solving?
No,
Awesome.
that is the only problem. Yes.
So on this one, just
Huh?
like I guess on the number 5, you moved the √3 over to the other side, and then you square root or you
Squared both
squared
sides.
it.
Yes.
Okay.
Yep. Just like that.
Because you can't do anything with like just a cosine.
But again, like I wouldn't worry about like if I was thinking about these kind of questions, I'd say like maybe 1 on the test is going to be tricky like this.
Okay.
The rest of it tends to be pretty straightforward with factoring and solving and like the double angle identities. I'm not going crazy on them, that's for sure. I mean, ask about the ones we don't know how to do for sure, but don't expect them all to be crazy.
I was just wondering, Miss Leiniger, so you said if you use a fraction, if it's just like 1 over sine or something like that, that it doesn't involve like cosine or something else. Do you have to double check those as well?
Anything that can have a fraction representation, yes. In the original problem. So anything that has a tangent in the original, anything that has a cosecant, secant, cotangent in the original. Because those all have fraction representations.
Okay, thank you.
Other questions we're stuck on?
There was a point on question 8 and 5 where it was, I'm just going to go to 5. It said like sine x minus 1 over cosine x equals √3.
Yep.
If the √3, let's just say it was 0, like how would you solve that from, like you wouldn't multiply cosine x because that'd be canceling, right?
Yeah, it would be rough from that point. If it equals 0, then you would have to multiply it over to solve it because there would be no other way, which would eliminate the cosine from your answers anyway. But that's kind of okay because if it equaled 0, the bottom doesn't equal 0 for it to equal 0, the top does. So then it would really just be worried about where does 1 minus sine equal 0.
Okay.
So in that case, it would work just fine because a fraction can't have 0 on the bottom anyway.
Okay.
But that's kind of an odd case. Yeah.
So like if you have like a lot on the top over a fraction that's like cosine squared x equals 0, and then you multiply by the cosine squared x to get rid of it, then that could be okay.
It would be okay. Yeah, only because the actual answer is 0. I don't love it, and I would try to avoid it, if at all.
Because I did it on number 7. I multiplied by like a cosine squared x. Is there another way to have done that?
7, I think I did a straightforward Pythagorean identity to replace. Like, I don't think I ever went to cosines until the end. Because tangent squared is one of our Pythagorean identities.
Yes.
I can replace tangent squared with what?
Oh, it's like 1 plus secant squared root?
I think it's secant squared minus 1.
Okay.
Yeah. So if I do that, then it becomes all in terms of secants.
Oh, okay.
And this is actually a good one to talk about because I feel like with one replacement, it makes it pretty straightforward here. Because I
Okay.
get 2 secant squared minus 2 minus 3 secant plus 3. I'd, just kind of shift things around here to make it look like a trinomial. And then I would factor just like normal. So again, yeah, like if we were talking about something like question 5 and it was equal to 0 instead of √3, there would be no other way to kind of work through that. But most times there are. Like this, you can avoid multiplying. And you're saying, okay, where is secant equal to 1/2 and where is secant equal to 1? Here's where I flip into cosines. So this is asking me where's cosine equal to 2 and where is cosine equal to 1. Another good review there is, can cosine ever equal 2?
No.
No,
Nope.
so get rid of that one and say originally cosine is 1. Because cosine is 1. And I still would do a mental check on this one because it involved a tangent and a secant at the beginning. Tangent is sine over cosine. And if cosine is 1, that's fine. Secant is 1 over cosine. And if cosine is 1, that's fine. So even there, if you got cosine equaling out to 0, that could be a problem. A lot of those will not work that way, but mental check. So cosine only equals 1, then at 0, over at pi, it would be -1, and we would not include 2 pi on that. Okay.
On 11, we don't have to go over it, but like, is that the same thing as like you square both sides? Because I kind of got stuck.
Yeah, I'm confused about that one a little bit as well.
Okay, I can look at that one. In that case, let me just see where I would go with this. I would say secant is 1 over cosine. Tangent is sine over cosine, which then tells me almost everything is over cosine in this case. So I would make 1 cosine over cosine. From here, I would then have 1 over cosine equals cosine plus sine over cosine. You can, because it is okay. Like I said, I try not to cancel out fraction or any functions, but it is okay at this point to cancel the cosines on both sides. However, if I did do that, I would have 1 equals cosine plus sine, which kind of gets me in a sticky spot. So rather than do that, I would probably cross multiply here. This would give me cosine squared plus cosine times sine equals cosine. I would then move everything to one side and see what I could do from there. This is not real pretty. Let's see. What could I do from here? Sounds ugly. What answers does it have? I could take out a cosine here, but that doesn't help me any more than it did. Some of these you do get to a place where you kind of just have to mess with it to make it work and think about something logically. Like in this case, I could factor out a cosine, which would give me cosine plus sine minus 1. And essentially, if I set my factors equal to 0 here, I would have cosine equals 0. And then this one doesn't really solve nicely, but it's basically saying sine plus cosine equals 1. So even though that doesn't solve algebraically, you can kind of think through that one. Cosine equals 0. Before I ever do that, go back and look at the original. The denominator is all cosine, so should cosine really ever equal 0? No. So I would eliminate that and just get answers from this. This is similar to one of the notes questions we did where we ended up with just sine is equal to cosine. And we just looked at our chart and figured out where our sine and cosine the same. This would be similar to me. If I looked at my chart, I could find some definite places where sine and cosine together equaled 1. If I look, for example, 0. Cosine or sine at 0 is 0 and cosine at 0 is 1. So added together, they would equal 1. So 0 would be a good place for that. I would then continue around my chart. Another place that it would happen is pi over 2. At pi over 2, sine is 1 and cosine is 0. Why would that be a bad answer there?
Because cosine's 0.
Cosine would be 0. Yeah, that would be a bad answer for that one. So I would just leave 0. What does it say on there? For 11, are there other answers? No, it's just 0, yeah. So for that reason, I would have reasoned through it that way. I'm sure there's an algebraic way to do that by like squaring both sides and working it out. If I can work it out logically, I would have just done that.
So if you have to do something like that, you're just looking for a place where they're both like the same, like they're both pi over 2 and equal 1, or like they're both.
In that case, I was just looking at my chart and saying, where in my chart, if I added my sine and cosine values together, would they equal 1? And clearly, like 1/2 in root 3 over 2, no matter what root 3 over 2, that's not going to work. Root 2 over 2, root 2 over 2 is still not going to be equal to 1. Same thing for root 3 over 2 and 1/2. So it's really just where there's 0 and 1 that they would add up. Now that I'm thinking about that one, because a lot of people I know don't like that. Going back to that one, if I had taken that and squared both sides, I think I could have worked it out from there. Because foiling that out would have given me this. Sine squared plus cosine squared is equal to 1. So if I subtracted that from both sides, it's going to cancel out the 1. And then where do we recognize this from? It's our sine double angle identity. So that's essentially saying, where is sine 0? Sine is 0 at 0, pi. Because of the 2x, I would have done other answers here. But going back to these, when we divide by, whoops, I skipped 2 pi. That's what I did. Okay, if we divide these by 2, going back to this, you would have then gotten 4 answers out of this. Pi and 3 pi over 2. If I went back and plugged them in, thinking about the original representation, at pi over 2 and 3 pi over 2, cosine would have been 0. So those would not have worked. And if I plugged back in pi, that would be a -1 on the left. And tangent at pi is sine over cosine, which is undefined. So that wouldn't have worked out either if I plugged it back in. So that's why 0 is the only one that ended up working out. But to me, that's actually harder than it was to just reason out where do sine and cosine together equal 1. Sometimes the algebra makes things a little ugly.
Can you explain number 3?
3 on the same page or on the next page?
On the same page.
I love 3. It's a factoring problem. It's very interesting. It's actually a trinomial factoring, even though it's not super pretty. If you look at this, it's set up perfectly once you move the root 2 to the other side. Thinking about factoring normally, if it was like a 2 cosecant, you would have said 2 and 1, right? So how can we take root 2 and split it up so that it factors?
Root 2 and 1.
Mm-hmm. If we just split it into root 2 and 1, and then we do the same thing with that one, using our factoring logic, that root 2 can't go here because that would give it a greatest common factor. So it has to go over here. And what would root 2 times root 2 give me?
2.
2. And we would want that to be positive, and then this to be the -1, because then that's what would give me -1 and 2 gives me the 1 in the middle there. So it's super interesting the way that one factors. I think you see that again, maybe question 13, or on the next page maybe. So that is when it solves out, set your factors equal to 0, cosecant equals 1 over root 2, and cosecant equals -root 2. I would flip those into sines. Sine equals root 2, and sine equals, why is that not writing there? Okay, -1 over root 2. First issue, do you see either of those for sines? No. Okay, root 2 is larger than 1, so we get rid of that one. How do we make the second one look like something that we're used to?
Multiply by root 2 over root 2.
Even though I don't make you rationalize, sometimes it's helpful to you. Then this is asking me the question, where is sine equal to -root 2 over 2? That's the pi over 4 value, and sine is negative in quadrant 3 and 4. So that would be at 5 pi over 4, 7 pi over 4. Okay. I kind of did a mental check on that one because it was a cosecant originally. The issue would have been if sine ever equaled 0, but that didn't come up here. Sine equaled root numbers, so it wasn't a problem. Other things?
Look at 12 on this page.
Well, let's see. Where would I have gone with 12? I probably would have started with replacing the tangent. So that gives me sine squared minus sine over cosine times cosine squared. So one of my cosines would have canceled. So I have sine squared minus sine cosine.
So you can cancel there?
What's that?
You can cancel there?
Yes, you can on that one. You can still simplify because there's still a cosine left. You're not fully eliminating it out of the problem. That's more of a simplification.
Okay, so when we get our answer,
I'm still going to go back and think about if I get cosine equaling 0, that's going to be a problem because I still have a tangent in the original problem.
okay.
So here, this would be kind of similar to the one that we did before where we just kind of logically thought it out. I would factor out a sine there, which would leave me a sine minus cosine, which isn't super nice, but I can kind of work this one out. Once I set my factors equal to 0, that's sine equals 0, and sine minus cosine equals 0, I would move the cosine to the other side because this would essentially just be asking me where are sine and cosine equal. Sine and cosine are equal at pi over 4 when they are root 2 over 2. Also in quadrant 3 when it's 5 pi over 4 because they would both be negative. Sine equaling 0 happens at 0 and pi. And at both of those places, that would be fine because tangent is defined as sine over cosine. And if sine is 0, cosine is not 0. So that would be fine. So kind of mental check on those, all of those answers would work out. Other questions?
I had a question on the 3 on the next page.
Mm-hmm.
So I know it's no solution because it's like a difference of squares.
Uh-huh.
But the first time I did it, I didn't use a difference of squares and I somehow got an answer. How do you do it without doing a difference of squares?
I did that one. I would probably make a replacement for either tangent squared or secant squared using my Pythagorean identities. So for example, I can replace tangent squared with secant squared minus 1 and then leave the minus secant squared. What's going to happen to my secant squareds?
Oh, they're going to go away.
So essentially I end up with -1 equals 1. Is that ever true?
No.
So you can't do it.
Can we do number 4 on that, please?
On this page? Okay. On this page, ooh, this is an interesting one. I would start by moving everything to one side. And you can also kind of play the what doesn't belong card in this one. The only thing that's odd is the cosine squared, which I can replace with 1 minus sine squared. So that, if I distributed, would give me 3 sine x minus 3 sine cubed x. Then I still have this plus sine x, or sine cubed x. And then I would move this sine x to the left by subtracting it. And now it's equal to 0. If I kind of move things around, this is then going to give me -3 sine squared plus sine, or sine cubed plus sine cubed is -2 sine cubed. 3 sine x minus sine x is -2 sine x, or positive 2 sine x. I would then factor out a greatest common factor. Just to make my life easier, if there's a leading coefficient that's negative, I would go ahead and take out a -2 sine x. This would give me sine squared minus 1. You can continue factoring from here. That's a difference of squares, sine squared minus 1. Or you can just set your factors equal to 0. because this set equal to 0 would be where is sine equal to 0. This set equal to 0 would give me sine squared equals 1. Square root both sides. Where is sine equal to either positive or negative 1? So sine is equal to 0 at 0 and pi. Sine is equal to plus or minus 1 at pi over 2 and 3 pi over 2. So I would work that one out that way. Lots of factoring on these pages. They're lovely.
Could you do number 13?
13 on this page?
Yes, please.
Yep. That's factoring. Let's see. Do I want to factor it the way it is? Yes, I believe I do. And I currently have a greatest common factor on the left. Let's just see what that does. If I take that out, that gives me sine to the 4th minus cosine to the 4th. That is a difference of squares the way it is. I might have to multiply this back together after this, but we'll just see. Sine to the 4th factors into sine squared, and cosine to the 4th, one of them would be plus cosine squared, one of them would be minus cosine squared. What does this turn into?
1.
1, which essentially eliminates it because multiplying that 1 by the 2 out front, that's just gone now. So I currently have 2 sine squared minus cosine squared.
Do you do difference of squares again?
There's not much I can do with a cosine and a sine singular ones. And I would honestly, at this point, probably replace one of the two of them and multiply things back together. Factoring got rid of a lot of stuff for me there, and I realize it's work to go back to this. So you can either replace the sine squared or the cosine squared. I would probably replace the cosine squared with 1 minus sine squared. Keeping in mind that I would then be distributing a negative. So that's going to be 2 sine squared minus 2 plus 2 sine squared equals 1. Now when I have it that way, that's just going to give me a 4 sine squared. So I think I can solve this with square roots. Moving the 2 to the other side gives me 3. Divide both sides by 4 and square root both sides. Some of you did forget on your quiz, so don't forget on your test. When you square root, what do you put out front?
Plus minus.
Plus or minus root 3 over 2. So I'm looking for where is sine equal to either positive or negative root 3 over 2, which means I'm going to get 4 answers for that one. So we'll be at all the pi over 3s. And just for your test, so I can talk about setup on this one, I might as well. Instead of having you upload a file for every single question, I set it up as 10 solving questions. One of them is the challenge. So that's just points for solving it. Each of those are worth 5 points for like just the answers. And then there's an 11th question that is a file upload for you to just upload everything like you do the homework. I think everyone was kind of capable of uploading one. It just got to be a pain to do all of them. So for that, for every single question, what you're going to do is type in your answers. I'm not asking you to use like math formulas and stuff. So for like that one, if at all possible, type them in like the order that they go in. So you would just type in literally pi over 3, comma, space 2 pi over 3. So just space them out. And I've put instructions in the test too, but you would literally do this. There are a couple of questions. Okay, so depending on the question and how many answers there are, I can put in a lot of different answer combinations. Getting into permutations and stuff. If there are 4 answers, there's a lot of ways you can put in your answers. So if there's a certain number of answers, I've asked you to like put them in the correct like numerical order, increasing like that, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, so that I don't have to enter 25 different answers for people to get them right. But most of them, I kind of put in all the options. Like if there's pi over 2 and 3 pi over 2. I put in the reverse order of that and stuff so that it's not marking things wrong for just being in a different order.
So it's going to give the score at the end?
It won't give a full score because I'm grading the last question. And to be honest, I don't know if you forget a space in between and I put a space in between the answers, like, is that going to count it wrong? I don't know. So it definitely won't be giving you a score at the end because of that 11th question, because that's all your work. And that's what the second whole half of the test is, me grading that.
Okay.
Still go ahead and do your work and your explanations. The explanations are a little bit different than the proofs, but a lot of you are doing a great job with saying, I don't really care as much about the solving parts of it. Like, you don't have to say add 1 to both sides. That's not always necessary because I can see that. But I really like the explanation on how you're finding your answers, because some of you are doing a good job of showing me like your quadrant pictures and saying sign is negative in quadrants 3 and 4, and therefore it's just these two. So I really like to see that reasoning, because that tells me a lot about how you're getting your answers.
So would you rather us just not tell you how we did the solving part and only how we discovered the answer? Or do you still want that?
I'm going to go with, if it's obvious solving, like add 1 to each side. I don't necessarily need to see that. But if you're like replacing Pythagorean identities or getting a common denominator, I like to see that kind of explanation. Mainly because I know some of you are capable of jumping steps on getting a common denominator and stuff. And then there are other people that I know are not, and Mathway is helping them do that. So that kind of stuff. If it's more complicated solving, yeah. But if it's add 1 to both sides, no. You don't have to write that in words. I'm not being that picky about it. Honestly, Mathway and Photomath and all of that actually give explanations. So if your explanation matches theirs, that's where I'm having a problem. If it's the exact words, because those are not words that we use in our class, and I know that.
So will we have to, is it to where like we can't go back?
Mm-hmm.
Okay.
Yeah, that's mainly for the cheating issues. So it locks each question, but you'll have your work still. So if something goes like massively wrong, then you can like write me a note in question 11 when you get to that with your work, you know. But yeah, I'm trying different things with this. So
Do we have a time limit?
90 minutes I left it at.
Okay.
I may extend it out to 2 hours if I hear stuff, but it's the same length as the quiz. And I felt like we were all good in under 90 minutes, and now we're not uploading a file for every question. So it's only 10 questions. So I feel like that should be okay.
Is the 10th question a bonus question?
The challenge question, you will get 5 points for just doing it or trying it. But if you do it well and get the answers, it can make up for mistakes you've made before, up to 5 points of them. So
Okay.
It is helpful. And we have done questions like it if you've actually been following along with us. So, other things, any other questions people are having?
Can we go over like one of the notes questions?
Any,
It was one. It was. Are you gonna do you want me to just tell you, or are you gonna pull it up?
I'm pulling it up, but tell me what page you're looking at so I can get there.
262.
262. Going back. Yeah. Which one?
It's number 4. So, like, I'm just kind of confused on the ones that like it's like x over 2. So when I get that you do like you find if it were just it's sine x and then equals root 3 over 2, and then you multiply them by 2. But why don't you like add 2 pi?
Oh, okay. Yeah, Aaron and I talked about this. Why don't you do that? So if you did, let's just say you did. Let's just say you're going to be cautious and add 2 pi. So sine is equal to root 3 over 2 at pi over 3 as well as 2 pi over 3. And let's just say on a test or quiz that think, well, I don't know whether to or not. So let's just go ahead and add 2 pi to each of these. In terms of thirds, that's 6 pi over 3. So that's 7 pi over 3, 8 pi over, 8 pi over 3. Now, if we multiply all of our answers by 2 to go ahead and get our answers for x, that's going to give me 2 pi over 3, 4 pi over 3, 14 pi over 3, and 16 pi over 3. What's the issue with those two that we added in?
They're over 2.
They're over 2. So go ahead and do it if you want to, but those are always going to be past 2 pi.
Always. So you just like don't even bother.
Yeah, because it's the difference between the 2x and the x over 2. So the 2x, when you divide, it's like shrinking it down so there can be more answers in there. The divided by 2 in the original problem, when you multiply it, it's spreading your answers out. So there's a larger chance of your answers that were even in the unit circle now going past it. Because we did an example where like, if I made that same exact problem, but it was negative root 3 over 2, that happens at 4 pi over 3 and 5 pi over 3. And those are my original answers within the 0 to 2 pi unit circle. What happens when I multiply those by 2?
They're both don't work.
Both already out. So this would technically be a no solution from the start, and that's not even with adding extra answers in. So when you're multiplying by 2, it spreads your answers out and it pushes some past 2 pi. So adding more in, those are always going to be past 2 pi because they were to begin with.
So say like we have like sine and then 4x. Like, do we have to do the? I don't remember what you said. Like, do we have to do the 4 rotations or like?
Yep. So sine of like 3x would be 3 full rotations. Sine of 4x would be 4 full rotations. We did talk about that because someone asked how mean I would be on that. I would never make you do more than like if it was a 4x, that first one would only have 2 answers for sure because that would be 8 total. That's a lot. I don't even know if I went out to 4x. I want you to know the concept. It's great. But for a normal test question, it's a bit much. Like that was the challenge question on the quiz, but I feel like that's okay for a challenge.
Yeah. Okay.
Yeah. Other questions? We all okay on everything else? There's no like you have to take it during the class period because of like the way I've set up the question banks and locking the questions. Just it's an hour and a half sometime today for second period and tomorrow for 5th and 6th. 5th and 6th, if for any reason you want to take it today, let me know because I can get you assigned to it. It's just I have to put it in there. It's not open till tomorrow for y'all. But I haven't really heard any people concerned about that. So.
All right. Homework, do you want us to resubmit?
Number 13 on the first page. Sorry, it's just
Hang on, 2 different things happened. Morgan, what about resubmitting?
I was just asking about this, like the review. You want to submit it, and I had some blank ones because I had some questions. So, do you want me to resubmit or?
No, I'm not real worried about that with the review. I wanted you guys to try. I'm trying to make it a review so that you can actually do it. Do something to prepare, but. Other than that, no, it's fine. And then I heard question 13 on what?
the first page.
The first page. On the first page, that is a greatest common factor question. Because of the tangents and secants, you would have to be careful with your answers. But I would take out a tangent. That would leave me root 3 secant plus 2. I would then set your factors equal to 0. Secant is then equal to -2 over root 3. So that makes cosine equal to negative root 3 over 2. So tangents equal to 0. Where does that happen? Tangents equal to 0 at 0 as well as pi. Cosines equal to negative root 3 over 2 at second quadrant at 5 pi over 6. And 7 pi over 6. I would kind of mentally check these answers with the original Tangent is defined as sine over cosine. So I'm not worried about the sine, but the cosine at 0, that's 1. Cosine at pi is -1. Those are fine. Secant is defined as 1 over cosine. Same thing there. Cosine at 0 is 1. Cosine at pi is -1. So those should be fine for all of them. Any other questions for me?
Wait, so really when we need to worry about the 0 on the denominator is only when like it's either when sine is 1, when tangent's undefined? Like with the 0 on the bottom? Okay.
0 on the bottom.
Okay.
Okay. All right. Any other questions or issues? No? All right. In that case, I will sign off with y'all. I think someone just emailed me about me making the test due by 10:30 today, which I did not want to do. So I'm going to go change that before everyone panics on me. Other than that, I'm going to